Hello, I am Tanisha Bharol from the team The Shoots. The members of my team include Sravani Sai M and Akhil Jayan. Our topic for the project is Sentiment Analysis of COVID-19 Tweets Visualization Dashboard. The problem which pertains to our project is the need for visualization of huge data on Twitter amidst the pandemic. So our proposed solution is a web app named Centralizer, which analyzes all the data related to COVID-19 on Twitter and provides useful results. And the site is made such that it is user-friendly. So this is a web app and it has 5 features of homepage, dashboard, localizer, news, and live analysis. So we'll start with the homepage. This page gives information about our app as we have discussed previously. So next we have shown the different parts of our website, and here we introduce our feature of COVID Info Bot, which is a chatbot made for user queries. So next we have provided some information on COVID-19 such as symptoms, transmission, and prevention. And this is our team, and you can reach out to us using the links given below of LinkedIn and GitHub. A major component of every page is our feedback feature, which inputs the user's emotion and adds it to its database to visualize. Next, we move on to the dashboard. In this, we have restricted our graphs to India, which shows the overall positive, negative, and neutral tweets recorded over 7 days. We have made different visualizations for the same. And here is the date-wise sentiment analysis of the 7 days. Which is a stacked graph. And next we have the line graph for the same. And then this is a graph which shows the average sentiment analysis over the 7-day period. Next, we have shown a beautiful word cloud which shows the frequency of the most used words. The bigger the word, the greater the frequency. The next section is the localizer. This provides the information state-wise which we can choose from the options. The graphs are of the same format as given in the dashboard. The next section in our navigation bar is the news section. The first block shows the overall statistics of India. The highlighted portion shows the dip or increase in the particular option. In the state-wise stats section, we can choose a state and show its statistics. Here we have made a time series graph from Feb 1 till now of the confirmed, deceased, and recovered people. Next, we have shown the latest tweets and latest news section from organizations like WHO and the Government of India. The next section is the live sentiment analysis. This section is analysis for the latest 100 tweets on COVID-19, and the data is updated in every 25 seconds. This is the overall result. And the graph is made according to the data, which is updated frequently. So now we can talk about the difficulties we faced while making this app and how we found the solution for it. In the Python coding part, we faced difficulty in the collection of data as labeled datasets of COVID-19 were scarcely available. So we had to fetch the data using Twitter APIs and then process them, which took a lot of time. The hack challenge was a wonderful experience and we learned a lot of new things in a short amount of time. We learned how to use different IBM technologies and our mentors were extremely helpful and would reply to all our queries very quickly. This was a great learning experience for our team.
Now let's take a look at the responsive version of our app. As you can see, our site can also be accessed through a mobile phone. Let me quickly show you around and then we will proceed with the explanation of Python code. This is achieved using media queries. We have used media queries to change the styling, orientation and the size of different elements and made them adjust to the screen size of a standard mobile phone.
Now we move on to the Python coding part.
Hello, I'm Sravani and I'll be explaining all the Python code that we've used in our project. The first step in our project is to download Twitter data. To do this, we have made a Twitter developer account which provides us with consumer keys and access token keys. These keys, along with the 3P library, allow us to open an authentication protocol to authenticate requests and download data. We have made a few lists to store the data that is being retrieved. Using the API.search method, we have made a cursor which returns the collection of tweets matching our query. The query that we've used here is hashtag COVID. So all the tweets which have the term hashtag COVID are in English language and dated between 1st July and 8th July will be extracted with this cursor. We further filtered the location as India and stored all the relevant data, made a data frame of these lists and exported it into a CSV which will be used in our sentiment analysis. The main code of our project contains various functions which perform the pre-processing of data, its classification, generation of CSV, which is used for developing the UI and generating a word cloud. These are the libraries and the lists which are used to store the results of our analysis. The first step after extracting the data is pre-processing it. The extracted tweets contain a lot of junk text like hashtags, usernames, emojis which should be removed for better analysis. Using the regex library and the NLTK library, we have removed all the junk text and stop words from our tweets. In our pre-processing function, we have converted all the text in our data frame into lowercase, used the regex and NLTK libraries, and corrected the spellings using textblob.correct. In our localizer, we have analyzed tweets according to 6 different locations. Now to do this, we have passed the original data frame and generated different CSVs according to the user location. Our datewise function is the main function which takes a CSV as input, converts all of its tweets and the dates that they were made on onto two different lists. Using the datewise library, different lists are made containing the text of tweets according to the date that they were made on. These lists are then sent for sentiment analysis using the process function. This process function calls the getSentiment function, which performs the sentiment analysis using TextBlob library. TextBlob library is used for classifying words into positive, negative, or neutral. It works on the algorithm of naive Bayes and pattern analyzer. The sentiment function returns a property called polarity, which is in the range of -1 to 1, where 1 means positive and -1 means a negative statement. The process function returns list containing polarities of all the tweets. This list is then given as an input to the overall T function, which classifies the tweets according to polarity and returns the number of positive, negative, and neutral tweets. According to the location, these results are appended into their respective lists. A data frame is made using these lists in our main function, and then this a CSV is made, which is used in our UI. We have also generated a word cloud. For this, we have performed frequency distribution over the pre-processed data and found the 500 most common words. We've made a mask using the Twitter logo. Uh, that is the reason why our word cloud is produced in the shape of the Twitter logo containing 400 most commonly used words. We have also added a COVID bot, which is made using IBM Watson Assistant. It makes the interface more interactive and can be used by the user to clear all the queries you might have about the virus. Now, Watson Assistant provides us with two different skills, dialogue skill and search skill. Both of these skills have been used to make our chatbot. Now, the dialogue skill directs the flow of the conversation. We have created a lot of intents, and all these intents have been linked to create a smooth conversation using dialogue notes. For example, we have a lot of questions that can be answered using our bot, like what is COVID, the symptoms, prevention, how it spreads, the masks, how to wear them, who should wear them, about the treatment, about the quarantine, and how one should wash hands. Now, the search skill can be used to answer the questions directly from the Watson Discovery collection. For example, all the questions that user might have regarding mask is answered using the search skill. These questions are directly searched as a query using these Watson Discovery collection. Now we have added a lot of web pages which have information regarding the virus, and the questions can directly be searched from all these pages and answered.
Hi, I am Akhil and I will be explaining about the user interface code. So our user interface is a web app which uses Node.js in the backend and HTML, CSS and JavaScript in the front end. First we will discuss about the front end. The front end we have the HTML UI. It is the base markup of our web app, and this markup contains the base design of the UI without any styling and animation. It is structured with proper naming of IDs and classes of different element tags, which ensures that it is easily accessible while styling them in the CSS. Now we will discuss about the parsing of the data. The data was available in two formats, the CSV and the JSON. The data which was analyzed through our sentiment analysis model was stored in CSV file, and the data which we obtained through APIs were in the JSON format. So first we will discuss about the CSV data. The CSV data was parsed using this function. In this function we use the fetch method to fetch a response of the CSV data, which was stored in the GitHub repo, and then we stored this in a data variable in text format, and this data was split at the line breaks to form tables, and this was looped through 7 times, which is the number of rows in the CSV data, and then again split at the delimiter, which is the comma of the CSV file, and then all the data was pushed to the globally declared variables to render the charts. The API JSON format data was also parsed using a similar technique. We fetched using the URL of the APIs and then stored it in JSON format and looped through the times of the length of the JSON format, and then pushed all the data into globally declared variables to form the charts and graphs. Now we will discuss about the visualization of data. For the visualization, we used a JavaScript charting library called apexchart.js, and first we did was read their documentation, and we read all the relevant information on how to render the charts, how to add or remove data sets, and then we use this information to render the charts of maximum user interactability and the maximum responsiveness. So every chart had many properties, but some basic properties that were shared by all the graphs were window apex. Using window apex, we could set common properties to all the charts on a single page, such as their theme, if they should have a grid or not, etc. And then we use chart. Chart is used to set the height and type of the chart, like the line chart or bar chart, etc. And then we used x-axis. X-axis is used to set the data on the x-axis, and we can also mention the type of the data. Using series, we can set the data on the y-axis, and this data in this we inserted the data which we passed in the previous section. We used all the properties to render the responsive and interactive charts for the best user experience. All the statistic reports, news, and latest tweets are displayed using different APIs. For news, we use Gnews API, and for the latest tweets, we use the Twitter API, and we passed them using the API JSON method and displayed them on the news feed section of our web page. Now we will discuss about the styling of our entire web page. Our entire web page is styled using CSS3 for normal screen sizes, and we designed each element to make the site more interactive and appealing to the user, and we used certain animations to enhance the user experience. We also focused on making our site mobile friendly and making it responsive to different screen sizes. We used media queries to achieve this feature. Using this, we could make the normal screen sizes styles to adapt to the mobile screen sizes by changing the orientation and size of different elements. This was the front end. Now we will discuss about the back end. So for this, we need to set up a backend server first using Node.js. So we would use a Node.js library, Express, to do this. Express is a web framework that lets us structure a web application to handle many different HTTP requests at a specific URL. So first we need to set up a listening port. This is how we set up a listening port. Process env port is the port which is provided by the deployment service, and if it is not available, then it would set the port to 300, which would run locally. Now we would use the listen method to set up the port. So first parameter is port, and then it is a callback function. If the app starts listening to this port, then this callback function would run, which would log it is listening at the port. Then we would use the express method static to provide the directory in which all the app files are. Now we need to create a database. So for this, we would use a JavaScript library, NEDB, which is a database library, which is a subset of MongoDB. Therefore, it is lightweight and easy to use, which makes it perfect for this project. So first, to create a database, we would use the new data store object to make a database named database.db, and then we would use the load database method to load the database if it is already been created. This will ensure the skipping of creation if the database already exists. Now we can use the insert method to insert the overall data which we acquired from the sentiment analysis. Now we need to set up post and get request routes. So for this, we would use the post method. The post method has two parameters. One is the endpoint, which is /API, and the second is a callback function which would run when we access it using the post method. So this function would take the request body and insert it in the database. So the get request also has a similar method, get method, in which we have the first parameter, the endpoint, and the second parameter as a callback function, and this callback function would find everything in the database and send it as a response to the front end. Now the live sentiment analysis part. So for this, we used the twit library and the sentiment library of the Node.js for the extraction of tweets and the sentiment analysis. So first we made a new tweet object to enter our credentials for the authentication, and then we used it to fetch 100 latest tweets with the query of COVID. Then we used the sentiment library to You analyze the tweets text part, and if the score of the sentiment was more than 1, then it is positive. If it is less than 1, then it is negative, and if it is equal to 0, then it is neutral. Then we saved it in a object sent and sent it to the front end using the get request routes. This function is set on a timer of 20 seconds, so it runs every 20 seconds, and real-time analysis of tweets can be done frequently enough without reaching the request limit. This data is updated on the front end with dynamically updating maps. Finally, we have to deploy this app. This app is deployed on the serverless deployment service from Heroku. We chose this as it fit the best for our deployment needs. This site is deployed on this URL, and we can check it out here.